Okay, I believe this is recording. Let's take a look at, I believe this is our day 3. I wasn't sure. I got a little bit, when I added some of the work problems for us, I got a little bit mixed up on the days that we've been working on this. But I think it was Thursday, Friday, and Monday of this week. All right, so let's take a look at problem number 1. Becky can deliver her newspapers in 40 minutes. It takes Cindy 10 minutes to do the same route. How long would it take them to deliver the newspapers if they work together? So we assume their rate of work is constant, that they work steady all the way through. We recognize here that our unit of time is in minutes. So if it takes Becky 40 minutes to complete one job on a per minute basis, she's getting 1/40th of the job done. Cindy apparently does it a lot faster in 10 minutes, and on a per minute basis, she's getting 1/10 of the job done. And it's asking how long would it take them working together. So that's our variable, is the number of hours, or no, excuse me, number of minutes needed for Becky and Cindy to complete the job. And we'll emphasize that they're working together. All right, so I've got 1/40 plus 1/10. Let's get it. Let's just add these two fractions together. We'll multiply this second term by 4/4 so that we have a common denominator of 40. So we've got 1 plus, well, 1 times 4 is 4. 1 plus 4 is 5. 5/40 reduces to 1/8. Take the reciprocal of each side. This flips and becomes 8/1. This flips, becomes x/1. So hey, x is equal to 8. So it takes them working together. They can do it in 8 minutes. So some type of a little summary that says that they can complete the job working together in 8 minutes. All right, on the next one, John can paint 4 rooms in 10 hours. He hires Sandy to help. They can do the same job together in 6 hours. If he lets Sandy work alone, how long will it take her to paint the 4 rooms? So that's what our variable is the length of time. And this time it's in hours. It's the number of hours needed for Sandy to complete the job when she's working alone. All right. So let's look and see. Excuse me. When they work together, what does John get done on a per hour basis? John gets 1/10 of the job done per hour. Um, we don't know how much Sandy can do on a per hour basis, but we know that when they are working together, if you add their work together per hour, that it took them 6 hours to complete. So let's solve for x by subtracting 1/10 from each side. Let's get a common denominator. I could get a common denominator of 30 by multiplying this guy by 3, this by 5. So I have 1 over x in the numerator, 5 times 1 minus 1 times 3. That's just 5 minus 3, which is 2. That's 1 over 15. If we take the reciprocal of each side, this becomes x over 1. This becomes 15 over 1. We're in units of hours. So this is how long it would take Sandy to do the job alone. All right. Working alone, it takes Jill 16 hours to tar a roof. Mike can tar the same roof in 12 hours. If they work together, how long would it take them? So let's let x be, this time we're again working in hours, number of hours needed to complete the job. And they're working together. All right, so Jill can get, on a per hour basis, 1/16 of the job done. Mike works a little bit faster. On a per hour basis, he can get 1/12 of the job done. We're wanting to know when they work together, what part of the job can they get done per hour. With 16 and 12, 2 to the 4th power, 16, 2 squared times 3. So 48 will be my least common denominator. 2 to the 4th times 3. Just take each base and the largest exponent that it appears, and you can see if I multiply this by 3 over 3, if I multiply this by 4 over 4, I'll have a common denominator of 48. 3 times 1 is 3, plus 1 times 4 is 4, and 3 plus 4 is 7. If I take the reciprocal of the left-hand side, I need to take the reciprocal of the right-hand side. 7 goes into that 6. 7 times 6 is 42. 48 minus 42 is 6. 6 and 6/7 of an hour is the length of time that they need, working together to complete the job. A winery has a vat with 2 pipes leading to it. The inlet pipe can fill the vat in 3 hours, while the outlet pipe can empty it in 9 hours. How long will it take to fill the vat if both pipes are left open? So these pipes are working against each other. So on a per hour basis, let's let positive be filling the vat, where negative work is where you're draining or emptying the vat. So on a per hour basis, this inlet pipe gets 1/3 of the job done, and its job is to fill. Well, on the 9 hours, if it takes the outlet pipe 9 hours to drain it, then on a per hour basis, it's getting 1/9 of the job done. But in draining it, we're going to call that the opposite type of work than filling it. So we've got 1/3 minus 1/9 is equal to, well, how long would it take? X is the number of hours needed to fill the vat with both pipes open. So with 1/3 minus 1/9, we need a common denominator of 9. Let's multiply this by 3 over 3. We get that 3 times 1 is 3 and 3 minus 1 is 2. If we take the reciprocal of each side, we get that x is 9 halves. Half of 9, 4.5, 4.5 hours. So if you accidentally leave the drain open and you're trying to fill this vat, then it's going to take longer than the 3 hours to fill it, because you're draining it is working against filling it, and it will take 4.5 hours, an extra hour and a half instead of 3 hours to fill the tank. So I'm sure that was an accident. If you're trying to fill the tank, you don't want to leave that outlet pipe open. We've got Rachel and Roger working to clean horse stalls. They work together. So X is, and again my unit is hours. It's the number of hours needed for Rachel and Roger to complete the job. Let's emphasize that that's when they're working together. So individually, we know that Rachel's rate of work is 1/4 of the job per hour. At the same time, Roger's helping not as quick as Rachel, with 1/5 of the job done per hour. Together, they would get 1/x of the job done. Let's get a common denominator of 20. Multiplying this one by the number 1, but write it as 5 over 5. Write this one as 4 over 4. That'll get us a denominator of 20, and 5 times 1 plus 1 times 4, 5 plus 4 is 9. If we take the reciprocal, we've got that 9 goes into 20 twice, which is 18 with 2 left over. So in 2 2/9 of an hour, they complete the job. We have Jed that can complete a deck. I assume that means building a deck on the back of his house in 6 hours. He has some friends, apparently Ted and Fred, stop by to help, and with their help, they all finish the job in 4 hours. So the question is, how long would it take Ted and Fred if they were working without Jed. So see, we're looking at Ted and Fred as a single unit, like they're one person, even though they're two people. We're looking at them as a team. So we have Jed that on a per hour basis is getting 1/6 of the job done. We don't know how much the team of Ted and Fred, we don't know how much they get done, what part of the job they get done per hour, but we know with both of them working together that they can finish the job in 4 hours. So X is the number of hours needed for the team of Ted and Fred to complete the job. Let's subtract 1/6 from each side. Let's get a common denominator of 12. Multiply this guy by 3 over 3. This one by 2 over 2. So this 1 over x. We've got 3 times 1, which is just 3, minus 1 times 2, which is 2, and 3 minus 2 is 1. If we take the reciprocal of each side, x is 12. So this Ted and Fred can complete the job in 12 hours. Now we don't know if they're good at splitting the work equally between them, or if Ted does all the work and Fred watches, or vice versa. We don't have enough information to get more detailed about the team, other than just say the team of those guys can complete the job in 12 hours. All right. I think this problem was actually on a previous assignment, but we can do it again. We have these two different models of heaters that their job is to warm a room, and the model 300 is not quite as good at it as the model 1000. It takes longer for the 300 to heat the room. It takes 75 minutes. The T1000 does it in a quick 50 minutes. Now, if we're trying to warm up a room and we have 3 heaters, one is this T300 and 2 of them are T1000s, how long does it take to warm the room? So that's my variable. X is the number of hours needed for the 2 heaters to warm the room. Alright, so it's not 2 heaters, it's 3 heaters. I've got 1 of these and 2 of these for a total of 3. I cannot count. So I have the 300 model is getting 1/75 of the job done per minute. One of the 1000 models is getting 1/50th of the job done per minute, and the other one's working at that same rate of 1/50th of the job done per minute. We want to try to solve for x. So what do we have? We've got 175, 175th. Now here these have a common denominator, and 1 plus 1 is 2, and we can reduce that. And here, let's multiply by the number 1, but let's write 1 is 3 over 3. So each of these would have a common denominator of 75 now. Y, I saw X, and I was thinking 3. I changed the X for some reason. Sorry about that. Common denominator of 75, and 1 plus 3 times 1. 1 plus 3 is 4. To solve for X, let's just take the reciprocal of each side. 75 over 4, X over 1. Is that right? I'm not even sure. I'm getting a little bit tired. And it sure is 18 3/4 minutes. So if you have a room that you want to warm up and you have these 3 heaters, these 2 models where you've got 2 of the T1000s, these 3 heaters can warm up your room in just under 19 minutes, at 18 3/4 of a minute. All right, I believe that's all. So, try to just write some type of a short sentence that says the 3 heaters can warm the room in 18 3/4 of a minute. All right, hope this helps, and I will talk to you later.